In this video, I would like to show you some examples of some somewhat unusual inequalities. Some inequalities that really require you to understand the true definition of the word solve. Solve the following inequalities. If there are no solutions, write no solutions for the final answer. Otherwise, write the answer in interval notation. Okay, now let's recall that solve means to list all the values that make the inequality a true statement. To solve an inequality means to describe all of the numbers that could take x's place and result in a statement that is true. So bearing that in mind, let's try and solve this inequality given in the first bullet point, where we have 2x minus 1 less than or equal to 5x minus 4 minus 3x. So let's start by cleaning this up. We can distribute through 2, and we can also combine some like terms on the left-hand side. 5x, take away 3x, I have 2x's in total on the right side. Now the next thing that we would typically do to solve this equation is to try and gather all the like terms together, to put all the x's on one side of the equation and all of the numbers on the other side. So suppose that I was going to move the x's to the left. So subtract 2x from both sides. And moving the numbers over to the right, I could, for example, add 2 to both sides. But let's see what happens when we finish cleaning that up. 2x minus 2x cancels out. And on the left side, 2x minus 2x cancels out. Negative 2 plus 2 cancels out. And so on the left-hand side, all that remains is 0. On the right-hand side, the 2x minus 2x has vanished because it's gone, canceled out, and negative 4 plus 2 would be equal to negative 2. Now this is quite a strange inequality because there are no x's. Which means that the truth value of this inequality isn't affected by the value of x at all. This equation is either always true, true for all possible values of x, or always false, false for all possible values of x. Well, let's see. Is 0 really less than or equal to negative 2? No, because 0 is larger than negative 2, negative 2 below 0. So this is false for all possible values of x. No matter what x is doing, no x will make this true. No matter what you do to x, you're not going to magically make 0 suddenly be less than or equal to minus 2. And since it's not possible to make this equation true, and numbers that make the equation true are solutions, there are no solutions to this equation. This is false for all values of x, and therefore there are no solutions. Now, let's try it again with a very similar inequality, except I've just made a very small change. Instead of having a negative 4 on the right side, I have a negative 2 on the right side. So let's distribute 2x minus 2. Let's combine like terms, 2x minus 2. If we like, we can then think about trying to move all the numbers and x's so that they are on the same side. But 2x minus 2x cancels out on both the left and the right. Minus 2 plus 2 cancels out on both the left and the right. And so I'm left with 0 less than or equal to 0. an equation which also doesn't have any x's. So now we have to ask ourselves, is this statement that we have obtained, 0 less than or equal to 0, is this true or false? This is a true statement because 0 is less than or equal to itself. 0 is less than or equal to itself. So this statement is true for all values of x. True for all values of x. This statement is true for all values of x, and therefore all values of x are solutions. Because every single possible value of x will result in a true statement. There's no way to make this statement false. Now let's convert this to interval notation. And we would have x's that can be as low as you want them to get, as high as you want to get, no matter what, any value of x, all the way down to negative infinity, all the way up to positive infinity, is a solution. One more time. This time, the change that I've made is I've turned that less than or equal to symbol into a less than symbol. So let's go ahead and do the standard thing, distribute, combine like terms, gather like terms together, and I result in the equation 0 strictly less than 0, where once again we have no x's. Now looking at this statement is actually false for all values of x. False because 0 is not strictly less than itself. And since it's false for all values of x, since it's false, we can conclude that there are no solutions. So in general, if you're solving an equation or an inequality where all your x's vanish, if solving an inequality where all x's vanish, if the inequality is true, is always true, then the answer would be negative infinity to infinity. If the inequality is always true, all real numbers are solutions, which is what we saw in the second example. 0 less than or equal to 0 was a true statement. Therefore, we had all real numbers for solutions. But if the inequality that you get is always false, then you can conclude that there are no solutions. If you have no solutions, that corresponds to an inequality which is always false, such as 0 less than 0, and such as 0 less than or equal to negative 2.